that feels like such an anticlimactic intro after hearing that awesome music and the scream at the end of it.
So just do a rock and scream right now.
Yeah, if you just play the music in the background during my entire talk. Yes. Talking about rock star development. That's too hot. Well, good morning. I'll go ahead and get started. It's 9 o'clock on the dot, so I want to welcome you and thank you so much for getting up for a 9 a.m. talk on the last day of the conference. So I hope you've had a great conference, and I hope you're not too tired from all the fun you've had. I was just kind of waiting a little bit, but I guess we'll go ahead and get started. So my name is Ben Ramsey. Thank you so much for coming to my presentation here on Friday morning. HTTP is dead. Long live HTTP 2. I am a web developer. I've been developing websites and web applications for, I don't know, almost 20 years, it seems, about 17 years. I've been speaking at PHP conferences for about 10 of those years. Currently work at ShootProof. We we are a platform for professional photographers. They can upload their photos, turn them into galleries for their clients. Their clients can view the photos and buy them and download them, or buy them and have them printed and shipped to them. So that's what I'm working on these days. I also am a co-author of the Zen PHP Certification Study Guide, which just had a 3rd edition come out. That's published by PHP Architect, so go check that book out. I'm an organizer at the Nashville PHP User Group. I used to be an organizer at the Atlanta PHP User Group. And I also am responsible and guilty for getting array column into the PHP language. So you can send me hate mail if you don't like it, I guess. It'll go into my trash box. And also, I need to change. I failed to do this on this slide too. I did it yesterday too. I have a UUID library. It's Ramsey/UUID, not Rumsa/UUID. It used to be Rumsa. So I changed the vendor name because it was too confusing for everyone. But long story short, Rumsa means wild garlic. And it's also a derivative or another word for Ramsey, which also means wild garlic. And I'm currently working on the League of Extraordinary Packages OAuth 2 client. So that's what I'm up to these days. Like I said, I work for ShootProof, and this is the gratuitous we're hiring slide. If you're interested in what we do, please let me know. And we are looking for a front-end developer mainly right now, but also growing our team in the future. So I'm also here to build relationships. If you're interested, let me know. All right. HTTP is dead. Long live HTTP 2. I thought I had a leak in my cup for a minute there. First, a little disclaimer. Despite this title, the talk is actually going to cover a lot of HTTP 1 stuff, just as much as it will cover HTTP 2. I don't want to jump too far ahead of myself, because I'll be discussing why that is later in the talk. But as you'll see, HTTP 1 is still important and relevant to our jobs as web developers. But now first, let's take a little bit of a history lesson. And I think the reason I'm doing this little history lesson is because I think it kind of is important to get a little bit of an idea of where we've come from. And HTTP is that protocol that we all use as web developers, whether you're really aware of it or not. But whenever you send anything through a web browser, like you put that URL into the address bar, you're making HTTP requests. And I think we've come a long way from the days of like 10 years ago where lots of web developers had no idea what was going on at the HTTP level. These days, it's more prevalent to know what's going on because we have to deal with things like AJAX and asynchronous requests and synchronous requests that are all going on behind the scenes. So we have to debug it a lot more. So we're much more familiar these days with things like the developer toolbars and taking a look at the network tab there to see what's going on. That didn't always used to be the case. Web developers rarely looked at HTTP 15 years ago. So let's take a look at history. HTTP comes from all the way back to 1990 when Tim Berners-Lee created this protocol for basically a single web server running at CERN. He created the first web server and served the first HTML page on it. And that version became known as 0.9 and was released in 1991. The only method it supported was GET. So it was super simple. But the beauty of it was that this was a protocol really initially designed for academics to help communicate their information to each other. So they would have hyperlinks that would link around their documents, and it was a way for them to communicate. Fast forward a little bit, they worked on, over the next few years, the IETF working group, with the help of Roy Fielding, worked on the first draft of HTTP 1.0, which came out in 1996 as RFC 1945. This version expanded the methods and headers, but it did not support things like the host header, which we take for granted these days. So basically, only one domain or one host could be used per IP address as a result of this. In 1997, HTTP 1.1 was published as, and this is probably going to be a little bit of a surprise, RFC 2068. A lot of times we're used to hearing the number 2616. I'll get to that in just a minute. This had many new headers and a few more methods. This wasn't quite the end of it, though, because in 1999, the version that we're mostly familiar with and have used for the last 16 years, really, was published as RFC 2616. Now, this was 1.1 as well. There wasn't a new version number. Basically, they just clarified things. They removed a few things. There were some of the things they removed, actually, because no one was implementing them, were things like the patch method and the link method. And there was a method called unlink. These have actually later been re-added back to HTTP through other RFCs. So in 2000, another update to HTTP came out, upgrading to TLS. This is just kind of a way, there was an upgrade header that allowed you to specify that you wanted to upgrade to a secure communications. But then we go on, and there wasn't a whole lot of work being done. I mean, we were all using HTTP to build websites. Our websites got more and more advanced. There was more and more data going across the wire. We were doing things that they never really even anticipated happening in HTTP. So what happens in 2007 is the IETF says, all right, well, HTTP has been around for a long time, and people are using it in ways that we didn't anticipate. And there's parts in there that are ambiguous and parts in there that are just confusing to people, and parts that people aren't even implementing. So let's get together and do another clarification. So they formed another working group called HTTP BIS, and they continued to work on this. And so they were, I'll get into HTTP BIS in a minute instead of jumping ahead of myself. But moving along, excuse me. Another RFC came out that updated HTTP, defining well-known uniform resource identifiers. I would encourage you to check that one out, but I'm not going to go into detail on what that does. A couple more came out, some clarification on the use of content disposition, some additional status codes. And then, in June of last year, we have a whole collection of RFCs that were published, 7230 through 7235, this is what I want to focus on today. And these are the updates or the clarifications to HTTP 1.1. So there's 6 of them in total. And then this month, that same working group published RFC 7540, which is HTTP 2. So when I say HTTP is dead, it's not really the case. RFC 2616 is dead. So delete it from your hard drives, remove all your links to it. It's not important anymore because now we have a whole collection of RFCs that you're going to have to keep up with. And I'll go through some of the highlights of what actually did change, because there were some changes that might be important and significant to you as a web developer. So RFC 2616 had been around since June 1999. It was massive. It was 176 pages. And if you look at other RFCs, you'll note that they're really, none of them are as long as HTTP was. There was a lot of errors that had built up over the years, and there was, as I've said, there was a lot of ambiguity in what it meant, or what certain things meant. And as I've also mentioned, the web got bigger than anticipated. They had no idea that it was going to turn into what it is today. So the HTTP BIS working group got together, and if you're not familiar with that BIS little suffix there, I wasn't familiar either. It is a Latin adverb for two. So like, if you think about adverbs, they usually end in ly, so this is the HTTP Thule working group. In other words, the second working group. They were chartered in October 2007 to refine and clarify HTTP, specifically forbidden from creating a new version of HTTP, but we all know how that turned out. So this was their charter, and in boldface I have, must not introduce a new version of HTTP. All right, so what did they focus on though? They took HTTP 1, as I said, and turned it into 6 different RFCs. We're going to go through each of these RFCs, and I'll highlight some of the important bits that, or at least the things that I found interesting, that I think you might also find interesting. But really, they were turned into these 6 things, and it was all really a lot of editorial changes, and so that messaging. Well, I'm jumping ahead of myself. 7230 or X is the new 2616. So let's take a look at that first one, 7230. Message syntax and routing. Well, what does that mean? That means that this is the RFC that defines basically how HTTP messages go over TCP. That's in a nutshell what it does. It defines all the architectural components. It defines HTTP and HTTPS. And it defines how these messages are going to be organized when they go over the wire. There are some important things to note here. The first one is that user info is disallowed now. So remember, like in basic HTTP auth, you'll have HTTP colon, or HTTPS hopefully, colon // and you've got like username, colon, password, @ and then the host name. That specific section is now disallowed from a URI scheme, or from the URI. And the reason I think is obvious there. It's for security concerns. These URLs would get cached in places. They would get linked in places. And so you don't want to do that. You don't want those URLs being exposed even in your own browser, specifically not a public browser or a proxy. And because they were in the URL, they were exposed. So now they're specifically disallowed. Multi-line headers are deprecated, and that's probably setting things up for HTTP 2, because headers are treated a little differently in HTTP 2. This is also an important key to setting things up for HTTP 2, and that is that the 2 connection limit has been removed. So if you'll note, HTTP had initially said that browsers should only make like 2 connections to the host. Now, I'll get into that a little bit later, but that means that we have to do some creative things to get around this connection limit, because we need to download lots of stuff now and not just a couple resources every time you load a page. But that's been removed. And then there's this new term that I wanted to throw out there because I felt like this is probably a term that you'll hear thrown around, and that term is effective request URI. It's a pretty simple thing, pretty simple concept, but this term itself did not exist in HTTP before. And what that means is you've got like an HTTP request that looks something like this, and so the effective request URI is, surprise, this full string, right? You take the host name and put it on the front of the path, and also if it was transmitted over HTTPS, then the effective request URI would have become HTTPS and so forth. So this is just something that allows browsers and implementers to be able to, there's a whole kind of construction of the request URI listed in the document. So they know how to put it all together to make this URI. All right, 7231, semantics and content. Now this is the biggest one, and this is also the one that we are probably most familiar with. So when you've looked at headers and request methods and all of that sort of thing, this is the document that defines that. So largely these things that we're familiar with are unchanged, but there are some clarifications that I wanted to highlight. So these are that safe methods have more strict requirements. So I'm missing my note here. So a safe method is one like get, head, and things like connect and options and trace. They're safe because they should not take any action on the server when you make that request, or you should be fairly certain that it's not going to take action on the server. And the reason this is important is things like Google Web Accelerator a few years ago was a plugin for browsers that would prefetch links and cache them in your browser to help speed up your experience, so that when you clicked a link to go to the next page, then it would already be there in your browser and just load instantly. Well, the problem with this, I hope it's clear what the problem is. If I'm on a page that's like, and I'm logged in, and my page is like, got this table of, let's just say that they're all user records, right? And every single one of those user records has a little delete link next to it. And that delete link is just maybe the URL is like, /user/ID, $delete equals 1, right? And so when I click on that, that goes to the server, and the server sees that URL query string parameter, and it knows to delete that user. Well, it knows that because I clicked it, and I knew that I wanted to delete it, and it has no way of knowing that I didn't click it. So when Google Web Accelerator sees these links, it assumes that they're safe to fetch. And because I didn't have anything else telling the user that they are telling the server that the user didn't intend this, the server just goes ahead and proceeds with this operation and deletes everything that was there. So that's why get is supposed to be considered safe. So as a developer, you have to be aware of that, because a browser can go ahead and make these requests if it needs to ahead of time, or anything else like that. So there's some more stringent requirements around safe methods, and I'm trying to remember what exactly they were off the top of my head. That's why I said I don't think I have my note's not here. So I'll try to remember it and think of it later. The body is now allowed on GET request. Now this is kind of an interesting thing, and I've seen a lot of people doing this in implementations. I remember talking specifically to Matthew Turland about this on some API things. And so why would you want to send a body on a GET request? I mean, you're just fetching information. Well, there's probably some reasons why you might want to do that. Now, specifically, it's allowed, but there's no context around what it means to have a body on a GET request. So that's really kind of up to you as an implementer, but they removed that restriction. Content range is banned on put requests, and that's just because it doesn't make sense. If you're going to put an object, put kind of assumes that it's the full object that's going from the client to the server, so content range doesn't really make sense. The expect header is no longer extensible. So expect is this header that you could put in and you'd say expect 100-continue. And basically what you're doing is saying, I want to know if I should finish sending the rest of my request. Is the server going to accept it? And then the server would see that, and in PHP we can't even capture this, by the way. Apache just responds instantly that it just responds with 100 continue before it ever goes to the PHP scripts. So there were a lot of broken implementations with this, though. People were adding new expect headers, and they just didn't make sense what they were adding. So they've now decided that expect really shouldn't be extensible. It will only ever accept the 100-continue value. All right, 201 is a status code that means created. And sometimes when you send a request to the server, if you're posting something or putting something, maybe more than one request is more than one resource is created. So now 201 has the ability to respond back and say, hey, more than one resource was created. It might have a location header with a link to one of those resources, but in the body, you might have links to other resources. All right, so this is an important one. If you're familiar with the history of the 300 series of status codes, 301 means move permanently. 302 means found. It used to be moved temporarily in early versions of HTTP, but what happened with the early implementations is that the browser would get a 301, and then if it was a 301 on a post request, for example, it would just send a GET request to the location, which might not be what you wanted. And then for 302, same thing. It would, if you sent a post request and you got back a 302, well, now you need to post to the new URL, right? But the browser would have just done a GET request to that URL and just done like what we know of as a redirect. So now what they've done is they've just clarified, they've introduced some new headers. 307 is now moved permanently, and 307 means you should post to this new location if you were posting in the first place, because that's what the server wants you to do. So they've now clarified this and just said, look, you can rewrite 301 and 302 from post to get. They've also introduced a new RFC. I'll show it up here in a minute, but this new RFC introduces 308, moved permanently, or permanently moved or something. They rearranged the words weird. But it means the same as like the 307, right? It's moved permanently, but you should, if you send a post request, you should send a post to the location that it moved to. So it'll allow the browser to redirect the post request. All right, 400, no longer limited to syntax errors. So this became like a matter of debate in like RESTful API communities and so forth, because in the text of HTTP, it said that 400 was for syntax errors. So if you had a syntax error in your XML or JSON, then you might send back a 400. But if you had a validation error, do I use 400? Do I use some other status code? Well, now they've basically just said, look, 400 is a good blanket client error code. It could be used for syntax errors, or it could be used for validation errors, and so forth. They have included a new status code, and this is super important for HTTP 2. That is 426 upgrade required. So the server can send back a status to the client that says, in order to do this, you need to upgrade. And it can give them some more information about how they need to upgrade. You could use this really for TLS. Like if you wanted to require the browser to be sending this information over a secure connection, you could say upgrade to TLS. But another way it's going to be used is to tell the client they need to upgrade to HTTP 2. All right, 204, and this series of status codes, they're now cacheable. Yes?
You can also use that for, say, your own version 1 of the API, update version.
Right, right. You could use that to tell people to upgrade to a different version of the API that you're using. This set of status codes, I don't think it ever mentioned specifically before that these were cacheable. People were caching them, and that's why they have clarified that they're cacheable without explicit freshness information. So they don't need to have an expires header or a cache control header. A proxy, for example, or your browser can cache any of these responses as needed. Another kind of interesting thing is we've been probably using relative URIs in location headers for a while, like for redirects and so forth. It wasn't explicitly allowed in HTTP. Now it's allowed. This is a cool thing, and I'll have links to these registries later, but we've now got a method registry that's official, and this document specifies where that method registry should live on the IANA website, iana.org, I-A-N-A. So I'll have a link to that later. But that's where anytime a new HTTP method is introduced, then it can go into this registry. Again, there's a status code registry for the same thing. And another thing that's interesting is that the content MD5 header was removed. This is something that a lot of people started using kind of more or less recently in APIs to designate whether or not the content had changed. But people weren't really using it consistently. People weren't using it very well. And especially like if you had different representations and you were doing content negotiation, well, that content MD5, should it change across different representations? Should it stay the same? So just due to like a bunch of confusion around it, they removed it. All right, so that's the big kind of document that defines all the status codes and headers and methods that we're used to. Now they've taken out some of the other things that were more or less just kind of side things that we should know about in HTTP, and that is conditional requests, caching, and range requests. So the next document is conditional requests. It just defines how to specify conditions to fulfill a request. So some of these things I find interesting are like eTag is defined as applying to the selected representation. So I just mentioned content MD5 being misused a lot because there was confusion over like what should that MD5 string represent? Should it work across all representations, or should it be specific to a representation? Well, eTag had the same issue. And an eTag is this identifier that identifies like the current state of the document, of the resource. So if a web page changes, then the eTag header would change because the web page changed. And you can use this in requests like put requests and delete requests in order to say, update this document if the eTag that I have matches the eTag that's currently on the server. And this allows you to avoid like race conditions or things like someone else has updated it in the meantime, so the eTag changed on the server, and that means that you really shouldn't update it with my changes. I need to go back and look at the new changes. So that's what eTag is useful for, and they've defined it as applying to the selected representation. So if you're dealing with application/JSON and versus application/XML, the eTag is going to be specific to one of those representations. They've defined there's a whole, like, I don't know how many steps it was, like 7 or 8 steps now, for defining precedents and evaluating when these conditions can match. So that's all clearly defined now. So that's the big thing on conditional requests. Range requests, this is that idea that I can say I only want this many bytes. So give me back just this many bytes in this in the response. So I mentioned content range a minute ago. It doesn't work with put requests anymore. It doesn't make sense. It only has meaning with 2 status codes now. And so they've done this because there was a lot of confusion over how people were specifying content range. And basically when the server responds with the range of content because you requested it, then it's got a content range header in it, For the part 206 is partial response, and 416 is range not satisfiable. So content range will be included there to let you know, which range of content you got back. They added a registry for range units. The only one right now is bytes, and that's what HTTP historically specified, but there was no registry set up to add new ones. So it was a little more difficult, and a lot of people kind of added their own over the years. Now we have a registry, so we can create new specifications for other kinds of ranges. And then multi-part byte ranges. I mean, it has the word multi-part in it, so you're going to think that it has to have multiple parts. It can now consist of just a single part if needed. On the next document, caching. It defines aspects related to caching and reusing response messages. Pretty clear there. Some of the things that they did, this document is actually one of the longer ones, aside from the semantics document, because it has a lot of substantial clarification to meaning of directives. They removed, or I'm sorry, they didn't remove it, they deprecated it. They deprecated that pragma header. So going way back, I think one of the earliest things I ever dealt with caching years ago was this pragma header, which isn't really clearly defined anywhere. And I think Internet Explorer loved to use it, but other browsers would use cache control. So they've deprecated pragma because over the years it just got misused, and there was a lot of confusion around it. I think it was mainly one that like Internet Explorer loved to use. They also originally had this 1-year limit on the expires header. So content couldn't expire greater than a year out, right? That was a limit. Now they've removed that limit, but they have, there's like wording in there that says something about please use a sensible expiration, or reasonable, or something like that.
Something beyond 2013.
Well, that's right. The world will end then anyway. So they've implemented a cache directive registry. So there's all sorts of cache directives that you can put into these cache control headers. So they've implemented a registry that allows extensibility for that. So now new people can add new specifications for different cache directives and add them to the registry. And they've also implemented a warn code registry. So there's when they respond back from the server, they're able to give you a warning code about the status of the cache. They can now expand that registry as well. And finally, they have created an authentication document, which is super helpful because we really didn't have a lot of language in HTTP about how authentication should work. It was left up to the implementer, which was a good way of saying we don't want to deal with this right now. So we don't want to specify that. They've added this authentication document that sets up a framework for specifying authentication in HTTP. They didn't necessarily specify specific authentication in this, but they have set up like the groundwork for how new people can come in and specify new forms of authentication. And they've also set up a registry for it. So this supersedes, there was another document called 2617 that specified basic and digest authentication. So this takes over for that. I think it obsoletes that. They've done things like Realm is no longer required on authentication challenges. And like I said, they've created a registry so that we now can add things to that registry like the bearer token and other things for OAuth 2.0, for example. All right, so registries and stuff, I've mentioned these. These are all just links to all the various registries. I provide them here so you can go check them out later and take a look at what's in those registries. I find this helpful because I get to go read up on different HTTP methods and status codes that are all just at a glance on a list. I don't have to sort through and go through all the big documents. I can go directly to this and find out what they are. And then there were actually 5 more RFCs that came out the same month, June 2014. Authentication scheme registrations. So that sets up the registrations for some authentication schemes that are already in existence, like bearer token that I mentioned. Method registrations, that sets up this registry, or that sets up a list of all the current methods we already know about to go into the new registry. 308 permanent redirect, I've already talked about, a forwarded header, and then this prefer header, which I find really interesting, but I wanted to show an example because it's really kind of hard to, like the forwarded header I think is easy to grasp what that is. Like a proxy forwarded this request and there's a header there that says it was forwarded for something or it was forwarded by something. But prefer is a little odd. So here's what prefer looks like. This is one example. There are two things the client can prefer right now. One is respond-async, and that will basically tell the server, I want you to go ahead and respond right away, like almost asynchronously, and then you can do the processing for what you want to do in the background. So right now, a lot of times we wait on the server to process it, and then it responds. Well, this says, go ahead and just respond with whatever you're going to respond with, and then you can keep processing. So in this case, it might not have been successful. It was just 202 accepted, is what I'm choosing to show in this example. And then the server can say, preference was applied, respond async. There's another one that's kind of cool. It's called return equals minimal. So the idea is that there will be other values here, but the only one right now is minimal. And so this is saying I'm going to, in this example, I'm going to create a new collection or a new item in the collection, but when you return back to me, just return the minimal representation. You don't have to return the full one. And so if the server can do this, if it knows how to deal with that, it can just give you back, in this case, 201 created and then a minimal representation of that. So those are kind of cool. All right. Let's go back to the HTTP BIS, this working group. They've worked to refine and clarify HTTP. They've migrated it from one monolithic specification to a total of 6 sizable specifications, all together, very monolithic themselves. And they've paved the way for managing new extensions easily through these registries. So what are they doing now? Where are we now? Well, in 2009, remember that charter? The working group must not introduce a new version of HTTP. Well, something happened a couple years after that. In 2009, Google announced their SPDY protocol, SPDY. And they said this is going to increase the performance of the web, or the speed of the web. And they wanted it to be an open protocol, but clearly Google, this benefited them more than anyone else, right? They were going to put it into their Chrome browser and put this on all their servers. And so anyone using Chrome specifically was going to take advantage of this protocol. And if the other browsers wanted to implement it, they could. In 2010, so Google released SPDY support in Chrome for all versions of Chrome 6. I'm having a connection issue with my phone. Then Google deploys SPDY in 2011 across all their services. So right now, I believe Google, I don't have any inside knowledge at Google's server systems, but what I'm told is that they're running SPDY on everything now. And so if you're using Chrome to access Google, and probably also Firefox and maybe even Safari, because all these browsers have support for SPDY right now. You're using HTTP, well, you're using SPDY, sorry. But then in 2012, something else happened. Continuing on with this path, Twitter decides to roll out SPDY support. Facebook announces plans to roll out SPDY support on their servers, and WordPress.com announces that they have support for it. So what happens now? Well, the IETF decides they need to amend their charter because something's going on in the world of HTTP, and they need to get like the standards body involved. So what they did, they amended the charter, and now their charter says the working group will leverage this to create a new major version of HTTP. So they opened up solicitations for what HTTP2 would be. And SPDY was the biggest thing. So essentially, draft 0 of HTTP2 was, I think, SPDY version 3 specification with a little bit of find and replace to replace all references of SPDY with HTTP. And then in May of this year, just this month, RFC 7540 is published defining Hypertext Transfer Protocol version 2. Let's try this again. Oh well. So why HTTP 2? There are some problems we face in HTTP today, and the HTTP BIS working group realized as they saw an increased interest in SPDY and proven results from using it, because they didn't just go into this blindly. They had results from Google showing how this was a good protocol and how it would be beneficial for the entire web. So they realized that a TCP binding protocol for HTTP was possible, our new one, while still retaining, this was really important, still retaining the message semantics with which we're all familiar. So we would immediately take advantage, or not quite immediately, but we'd be able to take advantage of this new protocol and this new speed that the protocol affords us, while still basically keeping the same method headers, keeping the same methods, the same headers, the same status codes that we've all used to date. So there's some reasons why we came to this. HTTP is an ASCII protocol over TCP. It's just plain text. And that's not very efficient. And even if you're using TLS, which will encrypt that and encode it, the packets could still be sent in a much more efficient manner. And that's what SPDY sought to resolve. But TCP is not going to be going away anytime soon, so we can't rewrite that protocol. And actually, it's a really good protocol for sending data. It's just that HTTP wasn't really using it very efficiently. When looking at the trend for some of the most popular sites on the web today, and what it takes to download their front pages, a clear trend emerges that we're seeing sizes in excess of like 1.9 and 2 megabytes just to download a page. That's a lot more now than ever was like 10 or 20 years ago when pages were super small, and we had to be small. Now in this day of more bandwidth, we are not afraid to force the users to download a lot more data than they used to. But that introduces some problems. The problems that introduces is that we might have tons and tons of objects that we're also downloading. Lots and lots of requests to get all these images and CSS and JavaScript files, and it increases or it slows down the way your site can load. Now this graph is showing over the last 4 years a trend, and this is just for the past 4 years. And you can see what, with this data that it's going to continue skyrocketing. So as you can see, like the number of objects that we download is well over 100 per page almost nowadays. And the transfer size is getting up almost to 2 megabytes. It's going to keep rising. And so we have to be aware that as it keeps rising, we've got to have a different solution. And while we've seen a great increase in bandwidth available to people over the last few years, we've not seen the same level of improvements in reducing latency. So the server round trip has actually not really improved quite a bit. I mean, we've got lots of bandwidth, but that round trip action to the server and opening that connection is an expensive process. And while there's this thing called HTTP pipelining that exists, and I'll explain a little bit more about that in a minute, most implementations have it turned off because it introduces more problems than is worth. So improving the protocol to make better use of TCP can improve this round trip and also decrease latency. All right, HTTP pipelining. In Daniel Stenberg's book, so this guy, Daniel Stenberg, who was a member of the HTTP BIS working group, wrote a book called HTTP 2 Explained. I'll have a link to that later I highly recommend this. It's a very short read, but it goes into more detail than I'm doing. But he describes HTTP pipelining like waiting in line at a bank or a supermarket. You just don't know if the person in front of you is a quick customer or that annoying one that will take forever before he or she is done. This is called head-of-line blocking. Sure, you can be careful about which line you choose, and you can create your own line, but once you're in a line, you can't change. And the overhead to create a new line is pretty high. So there's no great solution for this today. And as I've said, most browsers have this turned off because the head-of-line blocking is really bad. And so what's happening in pipelining is you're able to send most of these requests out kind of almost in parallel, but they still have to happen in a queue. And so that queue is going to block them, going both to the server and coming back from the server to the client. So as web developers, we've learned to deal with these issues. And we've written at length books, blog posts, and articles. We've given talks. I've given talks about this. We've created training courses, et cetera, and et cetera. We've built an entire industry around web optimization that specifically addresses these problems because we need to deliver web pages fast. So here's some of the ways we've dealt with these problems. Spriting. Are you familiar with sprites? So this is this concept. We've got all these little tiny images, or they might not even be tiny. We've got all these images we need to deliver, but when the browser is making tons of requests for all these different images, it slows things down tremendously. So it's actually more efficient to request one huge image that has all the images in it and just use CSS to pick which image you want from the sprite sheet. The problems with spriting, though, are obviously that you may only need one of those images, but you had to download the whole file, right? And the other problem is when you need to update an image in the sprite sheet, you've got to basically clear the cache for all the images. It's going to have to re-download the entire file. Another way that we've combated this is through inlining. So inlining using data URLs, we inline images. We've also inlined SVGs to speed things up. We inline JavaScript sometimes. We inline CSS sometimes. Again, this is really just about we're sending more data to the client on that initial request, but they're making fewer requests because the more requests the client makes, the slower things get. Another thing is concatenation and minification. So we've created whole tools and workflows to concatenate and minify our JavaScript and CSS files. And this is, again, to decrease the number of requests we have to make and also to decrease the amount of data we're sending over the wire. And a lot of times, though, we don't need all the functions that these massive files provide. We just need access to one or two of them, right? So there's a lot of inefficiency going on there, and the browser has to load it all in and parse it. Another thing that we do is sharding, domain sharding, or host sharding, to get around that connection limit. So as I mentioned earlier, HTTP 1 now has removed that 2 connection limit. In fact, in practice, no one was following the 2 connection limit. I think browsers were getting up to like 6 connections and so forth per domain. But we've gotten around that connection limit through domain sharding, which means we've taken all these different kinds of domains, like image domains, and we've appended them with like img-1, -2, -3. And this way we can get around that connection limit and serve images from all these different places, or serve images, all the images we need to make up that web page. So HTTP 2 attempts to fix these problems. Here's how it does it. It, first of all, is a binary protocol. Now, first of all, your reaction might be to get a little upset about this. After all, one of the benefits for HTTP developers is that we can maybe even open up a Telnet client and start typing raw HTTP, just the method we want, the path, the headers, and then the body, all there, and send that request all in plain text, right? But HTTP kind of makes it so we can't do that anymore. HTTP 2 makes it so we can't do that anymore. But it needs to be binary in order to make framing easier, and I'll explain frames in a minute. As a binary protocol, it's going to be easier to find the beginnings and endings of frames. Text is really hard to parse, and we've even found that through HTTP 1. It's really hard to figure out where things are sometimes. In addition, because it's binary, it also well, not because it's binary, but in addition to being binary, it also features compression and will mostly run over TLS. I'll kind of talk a little bit more about that in a minute. So you're probably not really going to be seeing text anyway for the most part. What's going to happen, and what's already happening, is that the tools we use will have to be able to parse that binary protocol so that we can still see the text that we're used to. And curl actually already has support for HTTP 2, and Wireshark, newer versions of Wireshark supports it. So it's a binary protocol, and they're arranged, all of the messages are arranged into binary frames. Each frame has similar properties, so there's things like type, length, flags, there's a stream identifier, and a payload. Now, HTTP 2 defines 10 different frames that are useful for communicating, but the two that map directly to the HTTP 1 features that we're familiar with are the data frame and the headers frame. For the most part, though, you're not going to have to worry about what the frames are that are being sent, because you're still doing HTTP 1 message and semantics. Now, the cool thing about the frames, and the reason they're so beneficial, is because of the multiplexing that's going on. So instead of having all these different connections open to try to send data, you only really need one connection. And that one connection can handle a multitude of streams going through it. And with either endpoint weaving together and interleaving frames across that stream. And so because the frames have a stream identifier, you're able to have them go kind of together and get interwoven together. So you've got frames from one stream and then frames from another stream and frames from another stream, all kind of getting sent across the wire. And then when they get to the client or to the server, they can be broken apart using that stream identifier. And this way, they can put together those frames and make sense of them. But because they can be sent mixed together, we don't have to worry so much about blocking. So that head of line blocking goes away. Another thing, and this is another reason streams and frames are so important, is because they can have priorities set on them and dependencies set on them. And for the most part, this is something that you're not going to have to worry about, but you need to be aware that the client can do this, because there's some really cool stuff that a browser can make use of this for. So for example, a browser could use this to specify which streams are more important and to tell the server that one stream is dependent on another. This allows them to do cool things like identifying which images should have priority to load over other images. For example, when a user starts to scroll down a page and they're going to start encountering other images midway down the page, the browser can say, I'm making these requests, these have priority over the images further down the page because they need to load first. Additionally, another good use of this would be when the user switches tabs in their browser. The browser could immediately switch the priorities on certain streams so that that tab, the streams that tab's controlling or using, would now take priority over the other tabs in the browser. Another thing that HTTP 2 does is header compression. This is because headers in HTTP 1 really started taking up a lot of space. And a lot of them had the same information over and over in them on every subsequent request. So that is a great place for compression, right? HTTP 2 sets up the framework for compression in headers, and then there's an additional RFC that was published this month for HPAC. And HPAC is a specific compression algorithm for HTTP 2 headers. So this feature allows the server to, server push allows the server to send other resources to the client in response to a single request. So for example, the browser can make an intelligent decision that says, all right, the server can make an intelligent decision. When a browser requests a certain resource, the server can say, okay, in the past when I've received similar requests for this resource, usually I get requests for these other resources right after it. So I'm going to go ahead and just send them to the client because the client's probably going to request them. And likewise, because you might think this could get inefficient easily if the client doesn't really need those. Well, there is a frame, a reset frame, that the client can then send to the server when it starts receiving these. So if it starts receiving a request or messages from the server and it realizes it doesn't need those, it can immediately send this reset frame, and then the server stops sending it immediately. And so in the past, we've not been able to do this, right? If I close a tab on my browser, because I didn't want to finish loading that page, it might still continue to load because there's no way of telling the server to stop sending that and to tell the client. The client could close the connection like completely if they needed to, but oftentimes that's less efficient than just letting it continue, because then it would have to open a brand new connection. So that's what server push is all about. Well, great, Ben. How does it affect me? Well, I've kind of been saying this a little bit. A lot of this is mostly seamless to us as web developers. However, there are some things like no more image sprites. We won't have to do that anymore. Inlining images is going to be a thing of the past. CSS and JS can be in multiple files now. It doesn't matter that there's going to be all these requests going on. And domain sharding is unnecessary and in fact might actually reduce performance in HTTP2 because you want just to have that one connection, and if you use domain sharding, you're going to have to open up a whole bunch of different connections to different domains. So awesome, I'm going to go do that right now. I'm changing all my sites today, but not so fast because we're still living in an HTTP1 world, and in fact, while browsers have some level of support for HTTP2, a lot of sites aren't going to be taking advantage of this, and you're going to have people who are on, we're going to have like mobile device problem all over again with HTTP1 versus HTTP2, depending on which client is using your server or using your application. So you're going to have to support HTTP1 users while you're also supporting HTTP2 users. So if you get rid of your spriting right away, you get rid of your domain sharding right away, your users who are still on clients using HTTP1, or they can only do one, are going to be experiencing latency and slowdown like they did back in 2001. Apache and Nginx still do not have official support for HTTP2, although they've announced that they're going to be adding that into their web servers. Firefox is perhaps the browser with the most support for this because every single draft that has come out, Firefox releases a new update to support that draft. So every single version coming out supported the draft in progress. And now the latest version of Firefox, I'm sure, supports the final. Chrome does offer support for HTTP2 in their development versions. I'm sure that'll change here very soon because the RFC was just published. And Microsoft has shown a tech preview for support in the next version of IE. I do not believe that Apple has made any statement about Safari with regard to HTTP2. However, that's going to have to change, right? Because they're going to have to support it. Curl and libcurl already have support for insecure HTTP2 and over TLS if curl is built with one of several different TLS libraries. Twitter already offers its services over HTTP2. And Google is in the process of switching all of its services from Speedy to HTTP2. And they will officially discontinue support for Speedy in their browser as of early next year. So Google is on board completely with this. They realize that their protocol is now HTTP2, so they're getting rid of all the Speedy support that they have in their infrastructure. Another things to take note of is that specifically in Firefox and Chrome, HTTP2 will only work over TLS. The browsers themselves will not support HTTP2 over insecure connections. Now, HTTP2 can work over insecure connections, but this is kind of a philosophical decision that the browsers have made, mainly to support your privacy and to make sure that people's connections are always secure. So that's something to keep in mind. So for now, we're going to need to keep up using our HTTP 1 tricks and until mass adoption of HTTP 2 is in place. But I think given a couple of years, we'll see widespread adoption of HTTP 2, and we'll start being able to take advantage of it until HTTP 3 comes out. And I will just briefly say they've already talked a little bit about HTTP 3, and one question you'd ask is, why already talking about it? Well, after it took 15 years for them to even release a new version of HTTP. Well, the reason is, with HTTP 2 and all the updates they've made to HTTP 1, or the clarifications, they've now set up a framework that'll enable more rapid development of new protocols that will not stomp on the old protocols. That was the whole idea here. So now we'll be able to introduce new features and new functionality and iterate a little more quickly in an ever-changing world. So thank you very much. Are there any questions? So yes, actually. So what's going to happen is your browser will have to send a your browser will have to let the server know that it can support HTTP 2, and it does this through this upgrade header. And the browser would send an upgrade header. So there's a little bit of an initial round trip, full round trip, to take advantage of it. But that's like a small price to pay to do the upgrade. So it would send a request with an upgrade header, and the server would then start sending all the next communications back over HTTP 2. Apache does have a module right now that will support it, but I imagine that that'll have to be built into to the engine itself.
Is that strictly for like protocol level upgrade messages, or can you use that to punch people who are still using IE6?
He asked, can you use the the upgrade required status code to punch people who are using IE6 to tell them to upgrade their browser? Maybe.
I think he's asking, does the spec say anything against
Oh, does it say anything against it? I don't actually know. It's, tells people to upgrade. I guess you could use it.
The issue with it, though, is IE6 does not support the response.
He says IE6 doesn't support the HTTP punch response. Any other questions? All right, well, thank you oh, go ahead.
Lovely, amazing talk. Super amazing. Love it. And delivery was fantastic. Love it.
Thank you.
What is the significance of the cards?
Oh, that's a good question, actually. When I was, I like to include imagery on my slides, and when I was picking out, and all of the images, by the way, are Creative Commons license images that I got off of Flickr, and also in my slides I've got links to these resources I wanted to mention too, but I also have links to all the photos. But I think I was looking for like an image of a king, and I just kind of like thought, oh, what about the Suicide King card like in a poker deck? And I just thought, so when I got that image in my opening slide, I just had some inspiration to start using the rest of the images as cards too. I'm not like a big card player. I just thought it looked cool.
So do you think we'll get an HTTP2 protocol then?
HTTP.
Hypertext Transfer Coffee Protocol?
Oh, the Hypertext Transfer Coffee Protocol. Will we get an upgrade to that? Maybe. Maybe April Fool's next year that'll come out. They always do an April Fool's RFC, or they used to, so that was one of them. Any other questions? All right, well, thank you very much. I'll post my slides. I will tweet a link to them. And please go to Joined In and rate my talk and give me some feedback on how I can improve it. Thank you.